What's happening, guys? Scott from Hornet's Nest. Welcome back to episode 21 of Tutorial Tuesday. As always, it's so good to see you. And in today's episode, we are finishing off the F-18 AMPCD module. And I can tell you, I am the most excited to have this done. Because 2 days ago, when I was finishing it all up, I just put the clear coat on. I popped it in the dehydrator like I always do. 35 degrees Celsius for about an hour, cures it beautifully. But for some reason, the dehydrator had a mind of its own, reset its temperature all the way up to 70. And if you know anything about 3D printing, that is way too hot for your prints to be sitting in. So when I came back thinking I was gonna have a beautiful module to film with, I came back to a warped, shrunken mess. It was way too hot. The only survivor out of it all was the aluminium milled bezel by PCBWay. So for the last 2 days, I have been turbo mode, recreating a whole new AMPCD to get this episode done. So I think it's gonna be a good episode. I'm gonna show you how to find the files so you can make it at home. I'm gonna show you how to prep it, print it, paint it, engrave it, where the circuitry is, as well as where the software is. And by the end of it, you're gonna have a beautiful AMPCD module as well. And you can take these tips and tricks and you can go and apply it to any other sub-assembly within the Open Hornet system, and you're gonna be on your way. So killer episode ahead. Let's get into it. Let's show you where to find these files. You want to open up your Open Hornet build package version 0.2.0. Now, if this is your first episode with us, go to episode 14. It's going to show you the Open Hornet system, the GitHub, and where to find it. So we open that up and we're going to drill down into the lower instrument panel. We're going to find the AMPCD module, and we're going to have a folder and a file. The file is the assembly file for the AMPCD module, and we're going to open that PDF up. The top left of most of the assembly files has the notes. It's going to have your finishing touches, the paint jobs, the specifications, even a couple of missing items that haven't been included into the exploded view. And then the right hand side is our legend. It's going to show the item number with its corresponding balloon, the part number, the quantity, its file name, as well as what it's made out of. We can have a look here. Balloon number 1 is the large AMPCD base. It is 1 required, that's its name, and it's made out of PETG. What I want to show you though, and I didn't even touch on it enough last episode, and a lot of you actually messaged about it, was item number 5, which is the bezel. If we zoom in, we can see the bezel is made up of 2 parts. Item number 5, which is the bezel itself, and then we've got the finger guards. Now I've gone and modified that file and I've joined them as one big piece. That way I could send them off to our friends at PCBWay and get it milled out of aluminium. And I can tell you, it looks absolutely incredible. Last episode, you saw the bare metal. Now here, we've put a metal primer on it, ready for today's episode. And I can tell you, it is well and truly worth the money. I'm going to put an order in for 2 DDIs as well, because they just look the best. Now, if you want one of these, and it's real simple to get, either Open Hornet by the time I've made this has their own modified file, or I can send you my one. I'll have a chat to them to see how we can get that out to you. But you're gonna wanna go to PCBWay.com and you wanna go to their CNC 3D printing tab and CNC machining. Drag and drop your selected files here. We're gonna open it up, and I've just got it in my modifications folder, and I've called it the AMPCD bezel _ A-18. And it's a .step file. That's what you're going to use. A STL or a .3mf file isn't going to work for this. It has to be a .step, and that's fairly easy to export that in Fusion. We're going to select it. We're going to choose 1 for the quantity, and it's in millimeters, aluminium, 6061, and the surface finish I'm going to select is brushed. We're going to come down here, we're going to make sure there's no threads or tapped holes, inserts, tolerances, surface roughness. I'm happy with the 6.3 micrometers. And then having a look, anything else we need? You know what? I'm going to actually select premium. It's going to put an extra charge in it, but I can tell you now, I've had to do no post-processing on this. I've literally been able to take it out of the box, give it a dust off, put some paint on it, and it looks wonderful. And then that is about it. Product description, and then you're going to be able to send that off. It's going to come out a little bit more than the $73. That's a just a projected cost, an engineer is going to get back to you, and I think it cost me about $130, $140. So it's not too bad, and I'm telling you now, if you have the cash flow for it, in the big scheme of how much your pit's actually going to cost, it's a drop in the ocean. So that's how you get them. Now the rest of the parts, and we can see their part numbers here, to find them we're going to go back to that folder structure under the AMPCD module, and we're going to go manufacturing. And then we have the rest of the parts. Anything that is the Microsoft Edge HTML document, it's actually a .svg file, is a flat cut file. It's what you're going to be laser cutting, CNCing, it's just your 2D profiles. Anything that is a 3D object or a .3mf is what you're going to put into your 3D printing slicer, and then you're going to print those out either using resin or PETG. And that's about it. If you want to go ahead, start printing all those, get that organized, I'm going to head across to the paint station now. I'm going to show you how I made my custom color for Gecko, and then we're going to show you how I prepped the knobs, engraved them, and then we're going to assemble it. Alrighty, here we are at the paint station, ready to go. Let's create our custom color very similar to the Gecko, which is the interior green that I've been using for the Cockpit's primer. It's going to be made out of 3 parts Tamiya XF3, which is yellow, and 2 parts XF5, which is their green. And then I'm going to mix it with a 50-50 ratio of paint to thinners, and I'm using the Mr. Color leveling thinner as it slows down the paint drying process, allowing it to level itself and dry incredibly smooth. With a small amount of paint like this in the color cup, I just cycle the paint through the pipette to mix it well. I try not stir it with a brush because you're just going to force paint up into the stem of the brush, and it's going to cause your brush bristles to spread out. Now that's mixed, let's connect the air hose, and I'm going to set the pressure to around 20 psi, and then I'm going to start applying light misty coats to build up the coverage, constantly switching between paint to air, back to paint, back to air. You'll see that I'm painting the bottom of the bezel first before moving to the top. It's because the Tamiya range is a fairly weak paint and it scratches easily. So by painting the exterior surface last, I'm protecting it from being bumped and scratched during the painting process, giving us that beautiful finish at the end. Whilst the top layer is drying, I clean out the airbrush. I create a mix of 60% thinners to 40% Mr. Color Super Clear 3, and it's a lacquer-based clear coat that replicates the finish of the paint underneath it. Again, build up the layers slowly. Because of how transparent this is, it is actually quite hard to see how much of the clear coat is going down, and you don't want to cake your model in the clear coat. You just want a light protective layer. Now that the bezel is protected with a clear coat, let's tape up any access point where the black paint can enter the interior, because I'm going to spray it as one complete piece. That way, when I do any maintenance on the piece later on, I'm going to be able to open up the AMPCD and we're going to have that beautiful interior green inside with the contrasting color on the outside. But before we assemble the module, let's add the Legend light plates to the bezel. These are pre-painted, so when I apply 2 coats of Rust-Oleum to the entire structure, I'm going to get the 4 coats of paint on the light plate, blocking that backlight beautifully. And the product I'm using to fix these is Microcrystal Clear, which is essentially a high quality PVA. It dries super clear and it fills in the gaps and allows me to pop these out if I ever need to change them. That's why I'm not using any super glue for this. With the rest of the model taped up, let's head outside, apply 2 coats of Rust-Oleum, and then we're good to go. With the main module drying, let's head back to the paint station, start working on the knobs and buttons. These are printed with another modified file. If you look at the assembly PDF, you can see that these buttons are actually made of 2 separate pieces. you've got the main button structure, and then you've got the arrow or horizontal dash inserts. Now this was designed this way because if you don't have an engraver at home, you can print them in 2 different colors. But I've got to modify these as well, and I'm going to load these up into Lightree. I've tilted them for the best quality, and then I'm using medium supports in the center and light supports around the exterior surfaces, and these pop off just beautifully with a bit of warm water once they printed. I print these with a 50-50 mix of clear and white Alegu ABS-like resin. It's going to give that beautiful vibrant white while still being backlightable. Even though that these look great out of the printer and they are super white, I still treat them to a coat of SMS Enigma white to give them a uniform finish to engrave to. Once the white is dried, I apply an arrow mask for the knobs that I cut out on my Cricut Joy Extra using a flexible vinyl. A tip with masking is apply your mask and whatever color you had underneath the mask, reapply that on top of the mask to seal it in. Masks, especially when you come around corners on these knobs, aren't perfectly sealed and you don't want that new color leaking underneath the mask. But once that's all dry, I'm then going to hit both the buttons and the knobs with a product called Mr. Surfacer 1200. It's a micro filler spray putty. It will help trap the backlighting image of how dense it is, but it also fills any of those layer lines that you're going to get from 3D printing. The final step for the buttons is to apply Mr. Color C317. It's an FS color for the US Navy aircraft gray, and it is the most perfect color match to the OEM knobs that I've got here. And you'll find that some companies will say they're at a federal standards color and it will have the numbers there, but the Mr. Color range just does it wonderfully, and it's a beautiful lacquer paint as well, so it's hard, it doesn't scratch, it's real durable, and it just hits the spot. Now that's the buttons done. Let's apply one final mask to the knob so we can paint the black identification stripe on them. And again, we're going to seal it in with the gray, and then I'm going to apply SMS's Camo Black. It's a beautiful lusterless black that just looks exactly like the OEM knob that we have in front of us. My favorite part of any paint job is the unmasking, but it's also the most terrifying part because you just hope that your mask and the seal worked, because it's a lot of effort to then just have it ruined. But these honestly just look beautiful, and I'm going to clear coat these just like the bezel with Super Clear 3 to ensure that these knobs stay looking good for a good while. I give these about a day or two to really dry nicely, really cure the paint, and then I'm going to install the buttons into a custom jig that I made, and I take them to the laser cutter, and I'm going to engrave the dash markings and the arrows into the buttons. And whilst we're here, let's grab the dried bezel and engrave that text as well. Alrighty, I've shown you how to paint it, let's get into building it. And the first thing we want to do is sort out our electronics. we've got the AMPCD button board, and we've got the DDI controller. And our friends at BuyDisplay have provided us with a 10.1-inch screen that Open Hornet recommends, and it comes with all the HDMI controllers as well as any sort of circuitry needed for it. The only things we're missing on this is the HDMI cable, power adapters, as well as the HDMI to USB converter. Well, how do we get these files? Because you're going to want to make them yourself. You want to send them off and get them done properly. We want to open up the Open Hornet build package. Again, you're going to be referencing this folder often, so pop it somewhere simple, and we're going to want to dive into the electronics folder. We want to hunt for the AMPCD button board PCB. We're going to open it up and we're going to be faced with a list of files. The BOM files are going to open up in Excel, and they just have a list of parts, quantities, and designators. They're going to tell us what we need for the board. The CPL file tells the manufacturer, this is where I want those parts placed and in what orientation. And the Gerber AMPCD zip folder is what we're going to send to the manufacturer, and it's got all the files in there to build the board itself. So let me show you again just where we go do that. I'm going to open up PCBWay.com, PCB instant quote, and then we're going to go quick order PCB. We're going to add a Gerber file there, and then we're going to find it under electronics, AMPCD, Gerber AMPCD, and it's going to auto calculate it all. Now, this one is a little bit more expensive than you usually see the $5 boards, just because of how big it is. But this little board here is nice and cheap. Anything under about 100mm by 100mm comes in under that prototyping PCB size. Well, that's the circuitry. If I take these out the way, and I just show you the screen, because I'm sure some of you will ask the question, because I asked it as well. How do I attach the screen to its controller? Because I actually, funny enough, had to Google it, because I've never done this before up until now. If you align them like this with the tongue sticking out and the controller, that way when we fold them, it's going to fold up underneath each other. You want to lift this black little tab. You then want to place the ribbon inside of the groove, and it's not going to go all the way. There we go. And then you're going to push down on the black tab again, and it's going to lock it in place. That is as simple as it is. And then this little controller here just going to adjust the power source and the coloring and all that. Well, that's electronics done. Let's get into the assembly. We're nearly done. We're going to load it up into DCS, and we're going to have an incredible module. So let's reconfigure the table, and then we're going to start building. Alrighty, so the first thing we're going to do is place the screen into the base, and we're going to fold up all of its electronics, and we're going to place it into the center of the structure. You're going to want to put the ribbon on the right-hand side, and there's a little slot designed for it, and that's the orientation that it's been designed with. Let's go like that, and then fold it down there like that. Okay, and you just want to make sure that nothing is pinching, and you want it reasonably centered. Now, there is a little neoprene strip that sits roughly around there, and that's going to kind of keep it all in place. But to align it, what we're going to do is take the screen protector off. We're going to place this on here. We're actually going to go and just use these two silver countersunk screws, and we're just going to lock it in place. That way we're getting an accurate position of where it should be. There we go. And this little strip is going to start on the edge of our screen, and it's going to extend inwards. Go. I'm going to let that gently sit there. It's not completely trapped. I'm going to unscrew it. I now know where it needs to go, and I'm just going to replace it properly. And this is actually not only just helping with its placement, but it's protecting that little part of the screen, because wires and that go through that area. Beautiful. That looks wonderful. Give it a nice little press, make sure it's nicely on. And then we are good to go to start the assembly. Let's pop our base to the side because we want to go and start assembling this area first. And the reason for that is there's some wires that we need to feed through the spacer past the screen, and it's going to be really hard to do that if we haven't done this already. So let's go and get the switches in place first. All that bottom nut does is just define how much space the switch sticks up. That's all it is. So adjust that how you see fit. Let's go and install the PCB now. We are going to want to turn it upside down, and let's install the wiring harness for the connector, which connects our button board controller to the button board itself. And it's also going to take out 12 volts as well for the backlighting. There we go. That's going to go through that slot there and then place it in. Lovely. And now let's go put the buttons on. Well, that is it. Let's go and pop the bezel on, and it's gonna lock those buttons in, and we're just gonna use those top two. Now, the hardest part about this is actually just aligning it. Oh my goodness, look how nice that looks. Oh, could almost have a mental breakdown right now about how good that looks. Wow, that's the best. That is honestly one of the coolest things I've seen. Well, let's get going. It's these tiny little ones that go here. And they just use a little Allen key. I don't even know what the Imperial, I think it's a 316. How do you guys do that? Just quickly do fractions in your head. Look, do you know how much simpler it would be to just be like, oh yeah, need a 2mm Allen key. Everyone knows what 2mm is. Everyone can picture it. No one's picturing what 3/16 of an inch is. There we go. And that's just gonna lock it in. The rest of these fix it to the structure. That is very cool. So next thing we wanna do is pop our little potentiometer in there, and then we're gonna apply its little knob as well. So we can flip that upside down. Take that little fixing washer out. We're just gonna place it in there. Look at that. Like a bought one. And then we're going to want to lock it down. Go. And then this little washer here, it's got a recessed detent in it. You got to line those up, and then it's got a little set screw on the back. Lovely. Ah! Oh my goodness, this just gets better and better. Now let's go, and this is what I'm talking about, that wiring loom that's going to be protected. These are going to have to come out the side here. We're going to have to find a way for them to come through. So let's pull this back across. Let's feed our switches in. The big one that you're going to see, if there is a gap here, it means our wire is just fouling it. So let's turn it upside down. You can see it, this one here. That red wire is stopping it from connecting nicely. And you see this power cable, you also want that to just come underneath it as well. There we go, that should be okay now. There we go. And you can feel it. Be very, if it's not screwing in gently, something's fouling it. These don't need a lot of pressure at all. Look at that. That is quite nice. Well, that's pretty much it. Let us go and pop these last screws in. Now, all of those push buttons clip in. They're actually modeled to just clip onto that switch. If you find that they're a bit loose or you don't like the tactile feel of it, and they feel just wobbly, you can use a bit of like shoe goo. It's just a flexible adhesive. Put it on one of the white tabs on the push button, and then it will just hold it nicely in place. Go. If you haven't been following along and it's your first time here, you haven't heard about the Open Hornet project before, like without the guys and girls at the Open Hornet team, this wouldn't be possible. Like the level of detail, the level of like thought that's gone into it, honestly, they're the ones that should be getting all the sponsorship money, because really they are really, really phenomenal. And if you want to go support them, go and subscribe on their Discord. Okay, let me just tuck all this away so we can just spin it over again. Last little bit is we want to put the heading course panel on. Ah, look at that. There we go. Reposition our screen because you don't want to see any of that silver, and that neoprene strip really holds it in nicely. You can just shuffle it and it's now not going to move. How do I get that? Look at that. That is incredible. That is probably the coolest thing that I've ever seen. Oh, wow. Okay, let's turn it over. And now we want to start just fixing up the wiring. What we're going to do is we're going to use a bit of double-sided tape to hold down our HDMI board. We're going to apply some double-sided tape on the back of this, and then we're going to stick that in there, and then we're just going to connect up all the little white connectors, and I'm just going to put in a temporary power solution into these two connectors here. If you are doing this at home, have a set of temporary power connectors. I've got one here that connects from ground and 5 volts and ground and 12 volts. That way you can test the entire system without needing to worry about having the full power supply unit. All right, let's get onto that. It looks so good. Like, just look at that. Now, we've got the screen loaded up. It's replicated my desktop as we're not in game, but oh, it looks so, so good. And this power cable fits nicely. That's all going to get hidden. Ah, boy, what a treat that is. That is just incredible. Now, yeah, well, let's get into the software of it. I'm going to show you how to get that real quick, and by the end of it, you're going to be on your way. What we want to do is we want to get into the J.R. Steenson GitHub. Best way to do that is get to your Open Hornet GitHub, go back a root folder, and it's going to show J.R. Steenson's, and that's where he's got Open Hornet software. Now the software package hasn't been fully released yet. It's still got bugs, it's still got errors, it's still being worked on. But when that does get released as version 0.3.0, then you're good to go. But if you want to give it a go now, this is how you're going to do it. We're going to open up the Open Hornet software GitHub, and then we're going to go and find this button here where it says main. You want to drop down and go to develop. It's going to give you your most up-to-date enhancements, and it's going to give you the AMPCD code. The main branch doesn't hold the AMPCD's code. It's got everything else, it just doesn't have the lower instrument panel. So we're going to go develop, the green button here, code, and then we're going to go download zip. And then we're going to go and extract that to a file location of our choice. Now we're going to open that up and we're going to go to the folder embedded, lower instrument panel, AMPCD, and we're going to open up the INO file, which is your AMPCD's Arduino file. Now there is something in here that I need you to have a look at and change if it's not looking correct. Scroll all the way down. You've got your line numbers on the left-hand side here. I need you to scroll down to line 104. It will define the AMPCD backlight A9. It's the backlighting pin for the Arduino. Now, this here needs to be reading 9, not A9. The reason is A9 is saying, hey, that's an analog pin. You cannot do pulse width modulation on an analog pin. If you are having the error where it goes from 0 brightness, by the time you get to 50% turning of the backlighting knob, it's gonna go full brightness. That's the error. It doesn't know how to pulse width modulate on an analog pin. So all we've got to do is delete the A and then you're good to go. That is just a little bug in the current system that hasn't been released yet. We want to go to the top, select our Arduino, which is a Leonardo. If you're using a Pro Micro, it's the 32U4 chip. We're going to select that and we're going to hit upload. That is as simple as it is. You just did it. It is going to look incredible. Now, watch episode 20 if you want to see how to get this thing programmed, but assuming you've done that, let's load up into DCS and let's get this showing how good it really does look. That is absolutely phenomenal. Well, that's all working. It is just so nice. Let's actually have a look at down the AMPCD here. Take that away. It looks better in real life than on the game. Oh, that just looks so good. So let us get BIOS operating. Let's select a port and follow the BIOS episode. There's two. There is the single port as well as how to connect multiple. You're going to want to do multiple once you get your PIT up and running, but I'm just going to do the serial port here as a single number just while we are testing it. Number 14. And you'll see all the code running. Oh, let's just have a look here. Oh my goodness, there is absolutely zero lag on that. Heading. Oh, you're kidding me. Oh, I just can't believe it. Well, let's select waypoint 3, waypoint target designate, come into the tactical page, hit FLIR. Ah, things are looking up. Let's just have a zoom in. Let's go. Oh my goodness, look at that. That is absolutely incredible. I'm really happy with that. Let's go here, tactical. Stores. Oh, you're joking. This is... wow. Let this inspire you to go build one yourself, because this is just to die for. And then let it inspire you to continue building an entire pit. And I'm sorry if your bank balance takes a hit, but it is truly worth it. There are a few things in life that are truly worth it. And this here is one of them. I just can't believe it. So yeah, I hope you enjoyed watching this as much as I enjoyed building it. Despite needing to remake half of it, it was an absolute ton of fun. And the Open Hornet team has put so much time, effort, design, and thought into building this to make it as easy as possible that you really just can't go wrong. So yeah, enjoy your week ahead. As always, stay safe. Enjoy your flight simming. I'll see you next episode. But in the meantime, I'm just going to be here enjoying this. Hey, it's me again. Can I just show you something quickly that I completely forgot to show you during that sequence? If we just go have a look here, this is the coolest part about it all. The backlighting. look how good that looks. It is absolutely phenomenal. Now, if we just turn the backlighting up a little bit, what I love about it is not too strong. It's not gonna blind you. And if you create a little bit of darkness there, you can see those identification stripes on the buttons. They're not super bright like a Thrustmaster DDI that are just like in your face. This is gonna look incredible at nighttime. Ah, oh, that's just the best. Anyway, that's all I wanted to show you was the backlighting as well. Go enjoy your week. Go build one of these and I'll see you in the next episode. Yeah, that's great. I love it.